Hi everyone, my name is Nakuba Shadia, and today we are going to talk about foundations of artificial intelligence in relation. I've integrated it with my AI-powered mosquito trap. Then this is my problem definition and problem context. The title is AI-powered mosquito trap. The goal is to identify and eliminate malaria-carrying mosquitoes, that is Anopheles species, using their unique wing beat frequency. And this is how it works. Data acquisition is through microphones in the trap, which captures audio, audio of the wing beat. Then the feature extraction, wing beat frequency is isolated from the audio signal. Classification, and machine, a machine learning module classifies the insect based on its wing beat frequency. Action, if it is identified, the Anopheles species, which is the target mosquito, then a trap is triggered, such as a laser that kills it, or a trapdoor is activated. Then from the course on Arison, we had many modules, and the first module was AI history and trends. First of all, what is artificial intelligence? This is the field devoted to building machines capable of displaying behaviors we consider intelligent, involving machines performing tasks requiring human-like intelligence. There are many dimensions of AI, such as thinking versus acting. This is how AI processes versus what it actually does. And machine-like versus rational. That's to say, mimicking humans versus optimal decision making. Then, in this module, there is also weak versus strong AI. What is a weak AI? Weak AI builds machines that act intelligently. Current focus. That is to say, machines that act intelligently, where strong AI acts aims for actual persons with consciousness and intuition. We talked about consciousness and intuition in the previous video. Historical insights. There were early AI research such as Alan Turing who discovered the Turing test. The continuation. This is how the AI trends is relevant to my project. Module 2, the second module was problem solving in AI and heuristics. First of all, we talk about I'm so sorry about that. First of all, problem solving, we define the problem precisely, analyze the problem thoroughly, isolate and represent task knowledge, choose the best problem solving technique. Um, Here we have the current state of the problem, the goal state, that's to say how we want our problems to be solved then, and then the the variables or the no not variables, the operations to be done on the problem so that we reach our desired goal. Then we have heuristic function. What is a heuristic function? This is a function that estimates how close a state is to a goal. I talked about a state. State is the current position of the current state of the problem. Then heuristic function is a function that estimates how close a state is to a goal, providing educated guesses to speed up exhaustive searches. Admissible heuristics never overestimate the cost, guaranteeing optimal solutions. Um, the third module, we talked about problem solving by search and game theory. What is a search? There are many search strategies, such as there is informed search and uninformed search. We also have the best first search, which combines both the advantages of depth first and breadth first search. What is breadth first search and depth first search? This is the depth and the breadth first search all fall in an informed search, which is not organized. Then this is finding a solution in not an organized way. But then informed search, here we use heuristic information to carry out research. Then we have hill climbing. This always moves to a better neighboring state but can get stuck at local maxima, plateaus or ridges leading to incomplete means. We have the game theory in AI. This provides a well-defined environment for testing AI algorithms, focusing purely on decision-making strategies. We have alpha beta pruning. This reduces maxima computation time by eliminating branches that will not affect the final decision. Um, Knowledge representation, fundamentals. This was our module 4. What is knowledge? First of all, there is knowledge hierarchy. This this is like this. It progresses from data, which are raw facts and figures such as numbers, one, two, three, any words, to information, which is processed data, and finally to knowledge, information with context and understanding. Then knowledge representation hypothesis. An intelligent system must explicitly represent knowledge and manipulate this representation which enables intelligent behavior. Then in knowledge presentation fundamentals, we have symbolic versus connectionist AI. What is symbolic AI? Uses symbols and rules to represent knowledge, often logic based. And then another AI, this uses neural network. It is neural network based, uses distributed representations and lines through connection weights. Then continuation, we have propositional logic, a formal language using this was a formal language using propositions. What are propositions? These are true or false statements connected by logical operators which are and, all, not, implies. How is this relevant to my project? Representing knowledge, the trap needs to know what constitutes a malaria-carrying mosquito's wing beat frequency. This this could be represented modified. We talked about first order logic. This involves de- declarative semantics. And what is this? This involves conceptualizing a domain, that's to say, objects, functions, relations, creating a formal language, writing true statements, and ensuring they are satisfied by intended interpretations. There are universal quantification for all and extension quantifications. There exist. We have axioms and theorems. All were in the first order logic. Inference in first order logic. What is inference, first of all? This is the deduction of deriving new information from the old one. There is a resolution principle, an important rule of inference for clauses used to demonstrate unsatisfiability and fundamental and automated theorem proving. We have soundness and completeness. What is sound means? N clause derived is logically implied. Resolution never derives false conclusion from true premises. Completeness. If something is logically implied, resolution will eventually derive it. Then we have reasoning under uncertainty and Bayesian networks. There is probability and utility theory in under this module. Probability theory handles uncertainty about facts. What about utility theory? Weighs the desirability of outcomes. We have sources of uncertainty. Bayesian networks, which include purpose, represent knowledge in uncertain domains. We have structure, Bayesian updates, all were in that module. Module 8, planning, fundamentals and scripts. Planning definition, reasoning after future events to establish sequences of actions to accomplish objectives. There is planning versus problem solving, classical planning systems, EG strips, representation, action schema components. Many were in that slides. But how is this relevant to my project, which is mosquito trap? The traps, that's to say, the traps planning involves sequential responses. Once a target is identified, it needs to plan, activate repellent, record data, wait for dissipation. Yeah. Then module 9 was all about advanced planning and MDPs. Real world planning, complexity, hierarchy planning, all of them were in that. Then continuation, there is policy, which is a mapping from states to actions aiming to identify. Then that maximizes. Let me first. That maximizes expected utility. Our module 10 was about machine learning fundamentals. What is machine learning? This is building computer programs that learn automatically from experience at the intersection of statistics and computer science. It is a subset of AI. There is machine learning philosophy, learning system architecture, types. The types of machine learning, we have supervised learning. This learns from machines learn from labeled data. Then we have unsupervised learning, where machines find patterns in unlabeled data. We have reinforced learning, machines learn from interaction with an environment. Project relevance. How is it relevant to my project? Module 10 continued. We have decision trees and dimensionality reduction. Dimensionality reduction. This reduces the number of features while preserving important information, mitigating the cost of dimensionality. Let me rectify it. Yeah, there are emerging trends such as deep learning, big data, real-time learning, and many other things. Thank you so much.